Hello, everybody. It is the last lecture before the midterm exam, so you are going to have your midterm on this Thursday. And as I told you that I'm going to solve you a problem today, two problems I prepared for you. And if you have any questions about regarding the exam and other stuff, please start asking now, so we can make any discussions about anything as you like it. Then I will start the lecture. Okay, any questions?
Our midterm exam, what topics will be covered in our exam?
I don't know. It covers everything from beginning to end. I mean,
6 week too?
from beginning to end, everything includes.
Thank you.
Yeah.
And could you say about the format of the exam?
Okay. So the format of the exam is this. I am going to prepare the questions and I will upload it on Moodle, but it will be only available when the exam time starts. Okay. So you will turn on your camera. You will join Zoom session. So you will keep your camera turned on during all the exam period, and it will be recorded. I mean, we are going to record. And at the same time, you will open Moodle and you will download the exam paper. You can print it out if you have printer. If you don't have printer, you can use the PDF copy. I mean, you can read it from your screen. Then you are going to answer everything on paper. I mean, you need a kind of plain and clean papers, like A4, okay, A4 papers. Then you will write all the answer down to the papers. When the exam is over, sorry, typically I ask like 4 questions in the midterm or 5 maximum. Then you are going to have around 40 minutes or 45 minutes. When your exam is over, you cannot write and you cannot make any changings on your writing, but you will have extra time to scan it and upload on Moodle. So you are going to scan all the exam answer papers, and you are going to upload them on Moodle. Okay, this is the way of the exam, how we are going to do it.
Thank you.
I think it is clear, isn't it?
Yes, it is.
Yeah, I am not pretty sure that if this is your first lecture, most probably you took hydraulics from me, and we did exactly the same thing in the hydraulics course. So it's going to happen the same way. I don't know. Okay, any other questions, please? No questions? Good. Let's continue with the lecture. Just give me 1 second, guys. I will be back in a second. Just give me 1/2 minute, okay? I will be back. Okay, I am back. Let's start. Okay, guys. As you remember that, I introduced you a very interesting topic. It is called specific energy in open channel flow. So you have already learned that any type of flow in open channel could be subcritical or supercritical. It means that there are 2 alternative flow conditions for any flow. Okay, so it is not easy to decide that if it is subcritical or supercritical, but we know that there are some rules, like you can calculate the Freud number, and or you can calculate the critical depth. Then you can make kind of comparison to understand that if the flow is subcritical or supercritical, then you will decide that if the flow is going to experience any change in alternative flow. I mean, it's in change in its flow conditions. So also you learn that this is specific energy curve, and for any specific energy, you see that there are 2 alternating depths, and then this is actually the main topic for the week. And now I'm going to solve you one more question to explain it, okay? So let's read the question together and what it says. And the temperature of the water is given as 10 degrees. It's okay. And the flow is 6 meters wide. So you see that in the channel, the bottom is 6 meter. And it's a rectangular channel. Typically we are, as I told you, that we are most of the time focusing on rectangular channels. This is quite typical. And the depth of the water is 0.55 meter. And the flow rate also given as 12 cubic meter per second. So the question is asking us that you should decide the critical depth, whether the flow is subcritical or supercritical. It is the second alternative to check if the flow is subcritical or supercritical. You can use critical depth or Froude number. Anyway, you can decide both methodology to check it out. And then finally, the question is asking you to calculate the alternate depth. So of course, you should first decide that if it is subcritical, then alternative depth will be occurring in supercritical flow. If it is supercritical flow, alternating depth is occurring in subcritical flow. So let's solve the problem. Okay, anyway, I am going to solve this problem. It's going to be a kind of additional information for you. And there is another problem. There's the next problem. Then I will allow you to use your time and you will solve the problem, okay? So let me solve this problem for you. And please note that what is the critical depth and other stuff, because you are going to use the same equations in the next problem. It will be good if you grab a pen and paper and note it. So as you remember that the critical depth is equal to this equation. I mean, you can calculate it by using this equation. And here, capital Q is the flow rate, and we have a bottom width of the channel if it's rectangular, and this is the specific. This is the gravity of acceleration. And if you put everything here, we know what is flow rate and other stuff. Then you can easily calculate that the critical depth is equal to 74 centimeters. Okay, around 74 centimeter. So let's check it out if it is subcritical or supercritical. And critical depth is larger than the depth what we have. It means that this flow is fast and it is supercritical. Okay, so you can easily say that the flow is supercritical because the depth of the flow is less than the critical depth. However, if you are not sure or like to make a kind of double check, you can also calculate the Froude number. And if you calculate the Froude number, this is the equation for Froude number. Please note that. And it's velocity over root square of gy. And if you calculate it, and you know that velocity is equal to flow rate over area, and then I put everything for you in the equation, and the result is 57. And as you see that this number is larger than 1, if Froude number is larger than 1, if the Froude number is far larger than 1, you can say that it is supercritical. So you see that the critical depth and Froude number are confirming each other, and the flow is supercritical. So we have double confirmation. And by making these simple calculations, you just already passed this, A and B. Okay. And now the last question is that the last thing in this problem we should calculate is the alternate depth. And for alternate depth, we know that the flow is supercritical. So let's first calculate what is the specific energy value. In order to find the specific energy value, we are going to use the depth of flow as y in the specific energy equation. And if you put everything together in this equation, then you are going to end up with 1.22 meters. It means that the specific energy of this flow is 1.22. And alternating depth is going to be a kind of flow which is higher than this critical depth, okay, 0.74 millimeter. So you are going to have a kind of larger, a kind of raised flow because the alternative depth is the depth in subcritical flow. And the specific energy is equal, as you remember from this chart. We have two specific energy. We have one specific energy for two flow, and now our flow is here, subcritical, supercritical flow. Now we are looking for the alternate depth at subcritical flow. So you will see that this is the critical depth, and the depth value we will find is going to be larger than what we have already. Okay, so and if you put everything into the equation, then you are going to get a kind of cubic equation. And in order to solve this cubic equation, you can use a kind of your calculator. And guys, please learn how to use your calculator to make a kind of cubic equation. And alternatively, you can use internet source, internet, but it might create some complication, because if people use computer and if you spend some time on screen in the exam, it is creating a little bit trouble. And we are recording the session, and later if your paper is subject to cheating or something, it may create a problem. That's why I strongly suggest you to use your calculator. Okay, use your calculator to calculate the cubic equation. And I know that Nazarbayev University approved calculators are able to make such calculation. Then you should sort this cubic equation by using a kind of cubic equation solver. There are 3 roots. The first one is 1.03. The other one is negative value. You will delete it because it is not possible to have a negative value. And the third one is y is equal to 0.55. And of course, one of the roots should be the same with the existing depth. So I confirm that it is the same. The solution is correct. And the alternating depth is 1.0.3. And the final check is, you should check that if this value, it should be higher than the critical depth. So we are around 1 meter and 3 centimeters. And if you go, you will see that critical depth is 74 centimeters. So it is higher than critical depth. So definitely this is the height, or this is the depth what we are looking for as an alternating depth in subcritical flow. Okay, is everything clear? I think it is easy to solve the problem, right? Do you have any questions, guys? Anybody has any question? Can you hear me?
You said about the cubic equation. Can I, for example, if my calculator is not able to solve such kind of equations, maybe write some approximate numbers?
Tommy, I suggest you to use your calculator and don't make any iterative solutions or numerical solutions. It is taking too much time. This is a very simple stage. And if you do that, time will be limited. This is online exam, and you will see that time will be given for you, not that much, okay? So if you lose some time by making some numerical equations, some numerical solving techniques, and most of the students are failing. They are just losing some time and complaining at that. So my strong suggestion is that just spend some time today, watch some YouTube videos and other stuff. I am pretty sure that your calculator is able to calculate a cubic equation. But if it is still not possible, as I told you that you can use the internet web page, as I provided in the link, the course, it is still possible, okay? But you should be honest, and you should not be cheating with the others. You should not be making search on internet and trying to find the solutions of problems. Just be careful and just spend your time. Maybe you can text me in the chat bar. You don't have calculator which is capable of making, solving such cubic equations, and you can send me a text message, or not a kind of chat message on the Zoom. And after that chat message, you can open the browser and use the online tool, okay? Then you can close it. So if we see any problem in your exam paper, and we are going to watch the video recordings, and most probably you will have no problem, because you just ask for request, to access that browser. So you will be fine. I don't know if it is clear. Did I explain myself well? So what I'm saying, that if you are going to use online tool, just send a message in the chat bar on Zoom, okay? And then I will give you permission to use it, okay? So then you can use it. And at that particular period, after your message, you will be able to use the internet browser to solve a cubic equation. But again, I am strongly suggesting you that it is a hassle-free and easy way. Use your calculator only. And of course, you can do numerical solutions. For example, you can end up with 0.56, you can end up with 0.5, it's okay. I accept it. Okay, 2 centimeters is not a big problem. It seems that you already solved it. But trust me, if you do a numerical solution, you are going to lose time. Time will be limited because this is an online exam, and you should remember from fluid mechanics, I am not giving you too much time. I am just giving you exactly the time you can solve the problems. Otherwise, I know that I have experienced that lots of students are cheating, and I am very unhappy with the situation. I don't know why, but this is turning into a very, very big problem. Okay, is it clear, Tomris? Did you get it?
Yes, yes, of course. Thank you very much.
Okay, Daniel, are you saying something?
Well, I just wanted to add that the problem with the calculators is the model that we usually have in the that we received from the university, this Casio FX83 GT Plus. It doesn't have the built-in cubic or the quadratic solver. So we can actually use it, but we have to manually program it every time to
I see.
to do this. Well, I mean, we could use other calculators such as like Texas Instruments if some of us has such calculator. But
I see.
that's the problem why people are concerned with solving the cubic equation.
I see. Thank you very much for this clarification, because this is also my experience in the earlier years. I mean, lots of students were complaining about, okay, because especially in classroom, you know that you are taking this exam in the classroom, there is no way that you can use internet, okay, because all the cell phones and all the laptops and computers are not allowed. You should only rely on your calculator. Okay, in classroom we are giving a little bit extra time, more time, because you are under the invigilator's response. I mean, there will be some invigilators and professors just watching you, and it's more comfortable place in terms of cheating. That's why we are allowing extra time in the classroom environment. But this is not going to be an online exam. You will not get extra time for making such calculations. Guys, definitely you will get such a question anyway. Okay, so just be ready to be able to solve for such kind of cubic equations. But the goodness is that you know one of the roots, okay? So as far as you know the one of the roots, it might be easier to solve numerically such a kind of cubic equation. I know that my students in this classroom, they are good at math, okay? They are good at math and solving such equations. So I am strongly suggesting you spend some time, make practice, and find a way which is comfortable for you. If you need to program your calculator, spend half an hour and program it, okay? It is going to save you time, as Daniel said, okay? If you are comfortable to solve such problems by numerically, and if you trust that I can solve it in a minute, do it, okay? That's fine, because I am only interested in the solution at this stage, okay? You are supposed to write the equation here, the equation, then you are supposed to write the roots of the solving, and then that's all. I am going to look only this part, okay? The rest is just totally up to you. As I told you that if you ask me for permission to use a kind of internet solver for cubic equation, I will give you that permission, but you should write first on chat, okay? Then use it. So you cannot use it randomly. I mean, if you use it yourself, and if I see that you are busy with this the browser, then you are going to have a trouble. Okay.
Okay. Thank you for clarification.
I think it is clear. So just get ready for solving such a cubic equation, and then I am pretty sure that you will find a way. Okay, guys. Any other questions? No? Okay, I am going to solve one more problem, then lecture will be over. Actually, this is the exam question. I asked this in last year, in midterm exam, okay? This is problem 4 in the midterm exam in 2024. So maybe you can test yourself right now, how you are able to solve such problems. If it is an exam question, your exam question, let's see that what you are doing. So the question is, water is approaching a gate, okay, a sluice gate, and the channel is 4 meters wide. It is B actually. The value is the bottom. It is the B value, and the flow rate is given as 18 cubic meter per second. And here, okay, there is a conflicting information here. But if the water has 0.40 meters, it is written here 0.45. So okay, solve this value by using 0.4. Okay. Anyway, you can use by 0.4 or 45. It doesn't really make difference. I'd like to see that how you are solving. So use the value given on the question, and I want you to find what should be the value here. So the knowledge what you need is that you see that we are not talking about energy loss. So basically you will assume that this is the same flow with the same flow rate in the same channel, but this is subcritical flow, this is supercritical flow. So it is quite simple that first we are going to calculate energy value, specific energy value, then you will find depth. Okay, please spend the time by yourself, and I am going to show you the solution in a minute. And I'd like to see that if anybody is able to solve it. And as far as I remember in the exam, the main problem was that some students didn't realize that this is a kind of problem or alternate depth problem. Actually, a Sluice gate problem is an alternative depth problem. So it is exactly the same problem as I solved a minute ago. There's no differences. The solution is totally the same, only the values are different. That's why I told you that note the equations. Any solution so far? Yeah, in my solution, I use 0.40. So you can use 0.40 to get the same numbers with me. And we are going to check. Okay, let me solve this problem. I think you are doing. Anybody has any progress? I don't know who is solving, who is not solving. Your camera is, I mean, all the cameras are turned off. Actually, it will be good if you turn on your camera.
We use the
I couldn't follow you, Daniel. Something happened. Your voice is not reaching me.
I mean, we're using the formula for the critical conditions, yes?
No, not okay. Let me show you the solution. Okay, guys, let's have a look at that. Somebody actually in the chat provided that RT is 6 centimeters per meter. Actually, it is John. It is 6.83. Okay, I think you just missed to put the point there, or centimeter maybe. I mean, your value is centimeter, right, John? So it is a specific energy value. Okay, so the specific energy is equal to this one, and let's look at that how we can calculate. You should put here 0.4. It is a depth on the right side, and then we have the flow rate, and these are the other parameters you should put in the equation of the specific energy. Then you can find the specific energy as 6.85 meter. It is actually equal to 685 centimeters. Okay, so it's quite easy again. Then we know that this is a kind of flow rate. There is no need to check. Okay, guys, don't spend time for if it is not necessary. And let's read the questions carefully. What it says that calculate the water height before the gate. And here there is no need to confirm that the flow is subcritical, supercritical, because we are sure that the flow here is supercritical and the flow is here subcritical. Okay, because this is a kind of Sluice gate. So there is no need to make any confirmation. Of course, if you do a kind of extra calculation for critical flow or critical depth, it is okay, but you are not going to get any point because it is not given in the question. It is not required, but do it to be sure if you want. And here, then after finding the specific energy, just write specific energy here and calculate the alternate depth, and you are going to end up with this cubic equation. And you should solve this cubic equation, then you will get 3 roots. And the first one should be exactly the same with the point. I mean with the depth you have here. Look at that. It is 0.4. and we have 0.4. Okay, and here we have negative value. It is not, you cannot use it, and the alternative is that 6.83 meters. So in this question, the water height in the beginning of, in the upstream flow, actually this is upstream flow. And also you should get familiar with the terminology. This part is upstream, this part is downstream flow. Okay, guys, noted that. Sometimes I do not provide, I will not provide the details of the flow, but I will just say that upstream flow or downstream flows. This is upstream, this is downstream. And the upstream is going to be 6.83 meter. Okay, that's all. Simple, see that? So I don't know if you are worried about the midterm exam questions, and that's why I selected this question to show you that. How difficult my exams in the midterm. So you may expect a kind of questions in that caliber. So you are going to get something minus and plus at the same difficulties. So okay, I think we should end now, because I have finished everything before the exam, which I am planning to teach you. So that's all, guys. Any comments, any questions, please feel free. No question? Okay, then thank you very much. The session is over. I see you on Thursday. Prepare your calculator, prepare blank and clean papers. Your Zoom will be open from beginning to end, and your attendance to the exam will be confirmed. Should be confirmed with the Zoom appearance, your appearance in the Zoom. It means that if you do not appear in Zoom but still take the exam, your exam will not be valid. So you should also actively, staying in the Zoom session. Your camera should be turned on. Be sure that you have a working camera. And also, I suggest you to find the printer if you have, to print out the question. And at the end of the, if you don't have a printer, it's still fine. You can use your screen. One more thing, just be sure that how to scan or picture your answers and upload on Moodle. Okay, most of the students, most of the students are having no problem in this part, but some students may experience difficulties, so make some practice. Okay, guys, it is over for today. Okay.
Thank you.
Thank you.
Tanya, did I miss something? Did you say something?
I just said that I have both printer and scanner. Can I use it?
Yes, it is free to use any scanner or printer. That's fine. You can use anything. Yeah. Any other questions? No? I think someone is saying something. No. Okay. Thank you, guys. See you next time. Bye-bye.
Yeah, goodbye.
Thank you. Goodbye.
Bye-bye.